The key terms for this experiment includes solid, liquid, gas, heat, particle, chemical reaction, endothermic reaction.
Hey guys, my name is Zach Davies and I'm your professor. Today we're going to check something out that I like to call gassy balloon magic. Let's have some fun. Now, the aim of this experiment is to investigate what happens when you mix two acid bases together. One being a solid in the form of carbon soda, and one being a liquid in the form of vinegar. Will a reaction occur? We're about to find out. The materials that we're using for this experiment today are a balloon, a plastic bottle. You can either use bicarb soda or baking soda. They amount to the same effect. A funnel as well as vinegar. Let's get into it. So firstly, we're going to measure out 3/4 of a cupful of vinegar as displayed here and pour it into our plastic bottle. Lovely. The second step of this experiment is we're going to place our balloon on the end of our funnel. And making sure it stays on because it's easier to roll off. Alrighty, once you put the balloon on the end of the funnel, the third step we're going to do is grab a teaspoon and then get a teaspoon of either bicarb soda or baking soda, depending on what you're using at the time. Pour it down the funnel. Give it a bit of a shake if the soda gets stuck. A bit of a tap. Just as so. That was a bit difficult. We're going to take off the end of the balloon. Now, this is the most important step that is going to be vital to your results. What you need to do now is the fourth and final step, essentially, is grab the end of the balloon, open it up as wide as you can, make sure the soda is staying at the bottom of the balloon. Then you're going to open it up, whack it over the top of the lid of the bottle and make sure it's nice and secure, so there's, just in case, you know, there might be some sort of spillage that might occur as a result of unsecurely putting on your balloon. And meanwhile, as you're doing that, just make sure that you're keeping your soda on the bottom end of the balloon here. Make sure none of it spills into the bottom. Now, after all the hard work is done, we're going to see what happens. We're going to grab the balloon, pour the bicarb soda, and as it hits the liquid, you can see the balloon inflating. Now, as you can see here, down the bottom here, the liquid, being the vinegar, has started to froth up a little bit. And you can see a couple of bubbles on the surface here, being, I suppose, the symptoms or the sign of a chemical reaction finally occurring. Now, how does this chemical reaction occur? Well, when the bicarb soda, being an acid, meets the liquid, being the vinegar, also being another acid, when those two acids combine, it creates a chemical reaction, in this case turning into a gas, with this active gas being stored here in this inflated balloon.
Let's look at this again. I release the chemical solid, which is the carbon soda, seen through the blue line. The yellow line shows the reaction it has with the vinegar, and the red lines show the gas particles that is released as the result, which ultimately inflates the balloon.
Now, in terms of the limitations for this experiment, there aren't too many. However, the one main struggle I had, which could hinder your result possibly, is you really need to make sure that when you attach the balloon on top of the plastic bottle, you just need to make sure that you fully secure the balloon completely over the top of the bottle. As if you leave any gaps between the balloon and the bottle, the gas that is obviously effectively going to be shot up into the balloon simply won't enter the balloon, and that obviously will lead to minimal inflation and a failure of results. In terms of variations, you can conduct this experiment without the plastic bottle or balloon. You can just simply add the bicarb soda to the vinegar in the cup and watch the chemical reaction unfold. But I would suggest that this way is the best way to conduct this experiment, as the use of the balloon on top gives you the students a very clear visual representation of what happens when the gas is released into the air. So guys, that's the end of this experiment today. I hope you had as much fun doing it as I did. Make sure you stay gassy.